Hi guys, today we're going to talk about circle vocabulary. So if you could turn your note packets to the first page, you'll see all these definitions and some pictures below. We're going to go through these definitions and I'm going to be referring to some of the pictures as we go through them. So the first definition you'll see says a circle. Circles, by definition, is the set of all points in a plane that are equidistant from a given point, and that point is called the center. So what that means is you start with a center point, and all the points that are the same distance away from that center will eventually start to form a circle. So if I were to continue going around that center point the same distance away, all of the points will eventually form a circle. So you have to start out with a center point. And you know that all of those line segments that I drew in are all of the radii. Now, congruent circles, it says our circles are congruent if and only if they have equal radii. That if and only if statement says that you can work both ways. And what I mean by that is you can say, if you know your circles are congruent, then you know you have equal radii. Or you can go the opposite way. If you know your radii are equal, then your circles must have been congruent. So it goes both ways. That's what that if and only if statement is saying. A chord. A chord is a segment whose endpoints are on the circle. So if you look down at the picture below, and I'm going to look at that very first circle, this segment DE is an example of a chord. It's an example of a chord because it's a segment whose endpoints are on the circle. Another example of a chord is a diameter. A diameter is a chord that has to pass through the center of the circle. So looking over in the middle, IJH is a diameter because it's a chord that passes through the center point J. A secant line is a line that intersects the circle in 2 points. And now a secant line also has to pass through the circle. So part of the line will be outside of the circle. So if you look at line KM, that line is an example of a secant line. It's a secant line because it passes through the circle, but it touches the circle in 2 spots, at L and at K. So that is an example of a secant line. A tangent line touches the circle in exactly 1 point. So looking at all of these circles down below, FBG is a tangent line. And that's a tangent line because it's touching the circle in exactly 1 spot. Now that 1 spot that it touches the circle is an important spot. That spot is called the point of tangency. And by definition above it says the point of tangency is where the tangent line touches the circle. So all of these lines are going to be important for you to know. You need to know what a chord is, going just through the circle and staying inside the circle. A secant line goes outside of the circle but still touches the circle in 2 spots. And a tangent line passes outside of the circle but touches the circle in just 1 spot. And that 1 spot is called the point of tangency. Now let's talk about arcs and angles of our circles. An arc is part of the outside of a circle. And there are 3 types of arcs. There's a semicircle. A semicircle is half of a circle, and the measure is always going to be 180 degrees. So if you look at our pictures below, a semicircle would be this portion here. Now you'd have to locate a diameter to know that you have a semicircle, so that way you know you've cut the circle exactly halfway. A minor arc is an arc that's less than a semicircle, so it's less than 180 degrees, and it needs to be named by 2 points. So an example here of a minor arc, we can go to, for instance, this next picture over here, and call TS a minor arc. So that would be labeled as arc, and an arc above the letters TS. Whereas a major arc is more than a semicircle, so it's bigger than 180 degrees. And you need to name a major arc using 3 points. So if I were to go around the circle in the other direction, I would have TUS. So I'm not going to just name it as TS because that's what I named the minor arc. I have to name the major arc using 3 letters so I know in which direction I'm going in. So TUS is the major arc. So again, you know the direction you're going in and you can clearly see that it's a major arc. It has 3 letters. Now, congruent arcs says if 2 arcs are congruent, then they have the same measure. They are congruent and their chords are congruent. So that's important, and we'll talk about that more tomorrow. Central angles. A central angle is an angle whose vertex is at the center of the circle. So let's try to find a central angle. Has to have a vertex at the center of the circle. So I'm going to go back to picture number 1. And a central angle. Now I'm talking angles, not arcs anymore. So I'm not on the circle, I'm an angle now. So I'm formed by line segments. So a central angle would be this angle ACB. That's a central angle. It's an angle formed at the center. Whereas an inscribed angle is an angle whose vertex is on the circle. On the circle, and whose sides contains chords of the circle. Meaning, to make an inscribed angle, you make it with 2 chords. So an example of an inscribed angle, I'm going to go to my picture with the triangle. An inscribed angle could be an example right here. And the reason that's an inscribed angle, that angle is formed here. We'll call it inscribed angle because it's formed by 2 chords. My chords are TS and TU, and the angle, that vertex of the angle, is on the circle. Now, an intercepted arc is the arc that lies in the interior of the inscribed angle. So looking at that inscribed angle, the intercepted arc would be the arc that's across from that angle. So the intercepted arc is the arc on the circle. Arc US is the intercepted arc. It's the arc across from the inscribed angle. So you have to know the difference between an angle and an arc. Remember, an arc is on the circle, and an angle is formed by line segments. It's creating an angle. An inscribed polygon is a polygon with all vertices on the circle. So looking at our pictures below, I'm going to highlight our inscribed polygon. So this one here is our inscribed polygon. And it's the inscribed polygon because if you look at all of the vertices of that polygon, all of the vertices lie on the circle. Whereas the other picture, which is the picture of the star over here, is not an inscribed polygon because the vertices that are inside of that star are not touching the circle. So therefore it cannot be an inscribed polygon because all vertices have to be on the circle to be called an inscribed polygon. And last but not least, we have concentric circles. Concentric circles are circles that have the same center but different radii. So this picture over here in the right side are concentric circles. They're circles with the same center but different radii. So now let's flip our paper to the next page. And if you notice the next page is blank, can you go ahead and draw 6 circles on this page? Anywhere on the page, any size, you just need 6 circles on your page. For the first circle, can you please draw a chord? In another circle, can you draw a secant line? For another circle, can you draw a tangent line? For another circle, I need you to draw a central angle. Now draw an inscribed angle. In the last circle, can you draw an inscribed polygon? Once you're done drawing all of your examples, why don't you check with a neighbor to see if yours looks similar? I will be checking these drawings tomorrow. Once you're done checking with a neighbor, you can then work on your homework. The homework is going to be pages 1 and 2 from the homework packet. Thanks, and I'll see you tomorrow.